In this video, we'll talk about an issue with the internal rate of return where the IRR rule that we discussed in the last video does not apply. Okay, so we have two projects over here, Project A and Project B. Project A has the following cash flows. You make an initial investment of $50 in year zero, and then you get a cash inflow of $70 in year one. In Project B, money comes in first. You get $50 in year zero, and then you need to pay out $70 in year one. The exact opposite of what we have for Project A. You can imagine a firm offering a subscription service to follow a model like that of Project B, where they take money in advance and then deliver products and services in the future where they also incur costs. Again, important thing to note is that both projects have the exact reverse cash flows. Now, both of these projects have the same internal rate of return, though, that's equal to 40%. Let's take a closer look at what's happening in Project B. Remember the IRR rule that we discussed in the last video? It states that we accept a project if the discount rate is less than the internal rate of return. Otherwise, we reject it. And we found out in the last video that is because we get a positive net present value when the discount rate is less than the IRR. You know what? Let's try that out with our Project B cash flows over here, and let's assume a discount rate lower than the IRR. Let's assume a discount rate of 20%, and let's figure out the NPV. So for year zero, it'll just remain $50, and for year one, gonna discount it by 20%. That's 0.2 raised to the power 1 for year one, and that's equal to 50 minus 58.33 or minus $8.33. So the NPV comes out to be negative 8.33. Something's clearly wrong. We took the discount rate to be less than the IRR. So we should be getting a positive NPV, but instead we are getting a negative NPV. We did follow the IRR rule, but it's not giving us the result. The deal was that I assume a discount rate less than the IRR and you give me a positive net present value. But I'm getting a negative net present value instead. This is happening because the nature of cash flows is different in this case. In this case, the cash outflow is occurring in the future. So every time we decrease the discount rate, the NPV also decreases. Let's try to analyze it in this manner. So you have 70 and you have 50, and just put the discount rate to be equal to R. Now clearly, if R decreases, the value of this whole term is going to increase because the denominator will decrease and the numerator remains the same. So value of the whole term increases, and since this value is in negative, you're gonna get a negative net present value instead. You can even verify this from the NPV profile for both of the projects. The NPV profile is just a graph of NPV at a range of discount rates. The place where the curve intersects the x-axis is the internal rate of return because the net present value turns out to be equal to 0. So you can see in both of these cases, for Project A and Project B, the internal rate of return is equal to 40%. First, you can check the profile for Project A, which is your typical investment project where you make an initial investment and then get cash flows in the future. It is downward sloping, and you can easily verify that at any discount rate greater than the internal rate of return, greater than 40%, that is, you get a negative net present value. You can see at 50%, you're getting around minus 5. So that checks out with our original IRR rule. But now the curve is upward sloping, meaning any discount rate less than the internal rate of return gives you a negative NPV, and anything more gives you a positive NPV. Exactly the reverse of the IRR rule that we have. So for projects like Project B, where the money comes in first and cash outflow happens later, you have this reverse rule that you accept the project if the discount rate is more than the IRR, otherwise you reject it. You can compare these type of projects to borrowing money from a bank. You borrow cash first and then you have to pay back the loan in the future with interest. In this case, the discount rate can be visualized as the interest rate. So if the interest rate is less than the internal rate of return, you'll obviously reject this project B and borrow money from a bank, right? Nobody wants to pay a higher interest rate. Projects like Project B are called financing type of projects, whereas Project A, which is usually the convention, is called an investing type project. Now you can see how this problem can be a potential source of error, right? So never use the internal rate of return rule blindly. First, you should always check out the type of project that you're dealing with, whether it's investing or financing type. All right, hope you got around that. This video is one of many in my corporate finance playlist, so do check that out if you need help with more concepts. I'll see you in the next one.